Today we'll be discussing about matrices. Matrix is a rectangular array of numbers which are arranged in rows and columns. So it's a rectangular array of numbers. So it can be a square array of numbers also, which is arranged in rows, as you can see here, 1 and 2, and column, that is 1 and 3. For example, A is a matrix, and as you can see the numbers are arranged in rows, so that is 1 2 3 4, and columns 1 3 2 4. Okay, now talking about the order of matrix. What is order of matrix? Let A be the matrix and A is given as 1 2 3 4. Okay, so it's a 2 by 2 matrix. Now here this first two represents the number of rows and second two represents the number of columns. So how will you find the order of matrix? You'll find it as order of A is equals to this m into n, that is 2 into 2, which is equals to 4. Then as you can see that here, over here, then the order is given by m by n. Okay, so you can simply multiply the row and column, number of row and column of the matrix, in order to get the order. Then now this order is denoted by A in square braces Aij of m by n, where 1 is less than or equal to I is less than or equal to m, and 1 is less than or equal to j is less than or equal to n. Now A is equals to Aij m by n is called as rectangular matrix. This A matrix is called as rectangular if m, that is number of rows, is not equal to number of columns, that is n. Okay, m is number of rows, n is number of columns. So if both are not equal, then it is said to be rectangular matrix. Let's take an example over here. 2 3 4. Now here, as you can see, 1 2 3 4 5 6. In this matrix, number of row is not equal to number of columns. How many rows? 1 row, 2 row. How many columns? 1 column, 2 column, 3 column. So it is a rectangular matrix. Now let's take another example, that is 1 2 3 4 5 6 7 8. 2 by 4 matrix. Here m is not equal to n. Okay, so 2 is not equal to 4. So this matrix is clearly a rectangular matrix. Let's take another example, 1 5 2 6, that is 2 by 2 matrix. Here our m, number of rows is 2, number of columns is 2. Okay, so m is equals to n. So this matrix is a square matrix. Now let's take a matrix, say A. A is equals to Aij of n by n. Then the line joining A11, A22, so on till ANN is known as the principal diagonal. So we will talk about it. So as you can see, let's suppose A is a matrix, that is 1 2 2 3 minus 1 0 minus 5 5 and 1. It contains all these 9 elements. Okay, so now here A11, this is A11, then A22, then A33. So all these 3 elements are called as diagonal elements. Okay, now we want to calculate the trace of this matrix. So what we will do, we will just add the elements of the principal diagonal. So this is called elements of the principal diagonal. Okay, so how will you find trace of A? Trace of A is equals to sum of the elements of the principal diagonal. That is here what it is, 1 minus 1 and 1. So 1 minus 1 and 1 is equals to 1. So that is trace of A. Now trace of Ka is equals to K into trace of A. Some properties we will see. Then we'll be seeing some properties of trace of matrix. Okay, So trace of k of a is equals to k into trace of a. Okay. Trace of a plus b is equals to trace of a plus trace of b. Then trace of a minus b is equals to trace of a minus trace of b. And trace of a into b is equals to trace of b into a. Now for first case we have to prove, that is k into a case we have to prove. So for that case we have k is equals to a and capital A is equals to identity matrix, that is 1 0 0 1. Then k is equals to a. So k into a is equals to, that's simply constant into 1 0 0 1. So constant into 1, constant into 0, constant into 0, then constant into a, 1 into a, that is a. Okay, so we got ka as a 0 0 a. Now trace of ka will be having it as a plus a, right, 2a. Then k into trace of a is equals to a into k, constant value is a, into trace of a is 1 plus 1 2, that is equal to 2a. Now we'll be seeing diagonal matrix. Diagonal matrix: if every non-diagonal element of a square matrix is 0, then the matrix is known as diagonal matrix. Non-diagonal element, that means here 1 2 3 are the elements of the diagonal, and apart from these 3 elements, all other elements, that is on the top 3 zeros should be there, and on the bottom you should be having 3 zeros, means those elements should be 0 apart from the diagonal. Okay, so only diagonal elements should be having some different values, and apart from those elements all the elements should be 0 on the top as well as on the bottom. Such matrix is said to be diagonal matrix. Okay, and generally diagonal matrix is a square matrix. No, obviously diagonal matrix is a square matrix then.